That average developer cannot spend a full year trying to figure out everything there is to know about Kubernetes. Majority of us wants to say, hey, this is my code, run it. First we got Docker, and almost everybody fell in love with Docker instantly. But Docker failed, especially Docker Swarm, at least when workloads in production are concerned. And it failed because the simplicity behind Docker was done at the cost of extensibility. We couldn't do much with it, and that failed to satisfy system admins, SREs, people who are taking care of our systems. So Kubernetes took over, but it has opposite problem from Docker. It is very hard to learn and hard to use. It satisfies the needs of people who understand the complexity of the systems and need to manage it at scale. If you take an average developer that is working on an application, be it Node.js or Java or Go or Python, or doesn't matter what the language is, but that average developer cannot spend a full year trying to figure out everything there is to know about Kubernetes. That's just too much. And trust me, it takes at least a year to understand the deployments and pods and services and virtual services and service mesh and what's not. It takes a lot of time to figure out Kubernetes, even to get to the bare minimum level that is required to define all the things we need to run our application successfully and to deploy them to production and to scale them in production. And it's complicated. Now, that might not seem complicated to you if you're a Kubernetes professional that dedicated his or her life to it, but for vast majority of people, it is too complicated. And let's be honest, developers do not need Kubernetes. What they really need is an easy way to deploy and run applications in clusters. That's what they need. I just realized that I said something completely wrong. I said developers. Everybody writes code today, and that means that everybody is a developer. But in this context, whenever I say developer, I mean people primarily concerned with development of applications for the business that they are supporting, and not necessarily people who are developing code to manage their systems. Anyways, what I'm trying to say is that it is unrealistic to expect that everybody will drop what they're doing and start learning Kubernetes in sufficient level of details to be able to define, deploy, run, and do whatever they need to do with their applications. Majority of us wants to say, hey, this is my code, run it. Operators and sysadmins, SREs, DevOps, I don't know how you call yourself anymore, but people that are in charge of making sure that systems are operational and healthy, they need Kubernetes, not everybody else. And when I say they need Kubernetes, I mean they need to go into the details of Kubernetes, while for everybody else, Kubernetes should be, how to put it, an implementation detail, just something that should be fairly transparent for the majority of people using. Actually, that's wrong as well. Everybody needs Kubernetes, but operators, sysadmins, and that type of professions, they need to go into the details of Kubernetes, while everybody else should think of Kubernetes as an implementation detail, something they shouldn't worry much about, something that is simply there and where we deploy our applications without much fuss. Just as with virtual machines, right? Very few people go into the details of hypervisors and what's not. Today, especially if you're running in cloud, if you want to run something in a virtual machine, you just click a button, you get the virtual machine, you put your code there, and that's it. That's how it should be with Kubernetes. And to get to that point, we need platforms. We need a layer on top of Kubernetes that will simplify deployments and many other operations without sacrificing the operational complexity that operators and sysadmins crave for and that they need, really. So such a platform should be opinionated, because opinionated platforms are the easiest way how to onboard majority of people, but it cannot be opinionated in a way like, hey, this is how software vendor decided you should do stuff and that's the way you do it and that's it. It doesn't adapt to you. No, it needs to be opinionated in a way that operators and sysadmins and SREs and whomever else has means to define what opinion for that specific organization or a specific team is. So we need a platform that will allow one group of people to fine-tune what the vast majority of the rest of the people in a company will need to successfully deploy and operate applications everywhere, including production. The problem with platforms is that many companies start by building their own platforms. You would put a bit of Helm, you would probably create some kind of dependencies of a base Helm chart that you would extend, and then you would put some OPA into it and open application model into it as well, and combine it with 57 other different tools and say, hey, people in my company, I just created a platform that you should be using, it's awesome. But there are quite a few problems with creating our own platforms. To begin with, it is much harder to do that than it initially looks like. When you start building your own platform, you think, hey, this is something that I can do in a few weeks, and then few weeks become few months, and few months become years. Over time, you're realizing that the complexity is much bigger than it initially seems. Even bigger problem with platforms is to keep up with the advancements of technology. If you create your own platform, you're most likely not going to be able to follow all the advancements coming, especially within the area of Kubernetes. Simply put, advancements are coming so fast and in such a high frequency that keeping up to date whatever you cooked in your own shop is close to impossible. And over time, the drift between what industry has and what your platform is going to expand and expand, and you will get to the point that the difference between what you built and what the industry offers as a whole is so huge that you will most likely going to have to abandon your platform, or even worse, you will not be able to because you're so customized, so special, that you will not be able to switch back to where the industry is. So to summarize, we need a platform that will simplify deployments and other operations for people who are not really experts in Kubernetes, because we want to enable everybody to do their own things, but everybody cannot be on the same level of expertise to define everything that needs to be defined. Such a platform would need to be opinionated but flexible at the same time. It cannot be only one or only the other. It needs to come with some predefined good practices, how to do things in an easy way, but at the same time, it needs to allow operators, sysadmins, people that are really deep into the system to customize what those opinions are so that they can fit into specific models and use cases of each organization or even each team in an organization. Now, one possible solution, one possible such platform could be Shipa, and we are going to explore a part of it today. To be more precise, we are going to go through Shipa from the perspective of developers or, non-system level people. And in one of the upcoming videos, we're going to go through Shipa from the operator's perspective. So think about it while watching this video. This is from the developer perspective, and operational perspective will come soon, I promise. So let's explore Shipa for developers in 20 minutes or less. Let's talk about setup first. What did I do before I started recording this session? And that's not much. I created a Kubernetes cluster and I installed Shipa through a Helm chart. That's about it. Those are the only things I did before I started recording. And you will find instructions how to do the same things in a gist, together with all the rest of the commands I will be executing today. And the gist is in the description of this video. So go and check it out if you want to follow along, or if you want to maybe reproduce what I'm doing at some later time. Let's go through a couple of scenarios. The first scenario is that I have a container image that I built through some other means, doesn't matter how I built it, and now I want to run an application based on that container image inside my cluster. And to do that, I need to choose one of the platforms that are available inside of my Shipa instance. So let me list the platforms that are currently available, and that's Shipa platform list. Right now there is only the static platform, and that might be just what I need, because static allows us to deploy an application, or to be more precise, to create all the Kubernetes resources required to run an application based only, exclusively on a container image. So let me create an application, Shipa app create, and then I will call it DevOps Toolkit. I will say static, that's the name of the platform I want to use, and the team to whom I belong. Right now I will use Shipa admin team because I will go through the teams in an upcoming video. For now I will use the one that is available by default when Shipa is installed. Later on we are going to explore how we can create different teams with different perks for each team, but for now I will use Shipa admin team. I will be an admin. Creating an application does not deploy anything. That's more like a placeholder, let's say, for an application that will be deployed in a couple of moments. So now that I created an application, let's deploy something. Shipa app I want to deploy, and the application to where I want to deploy something is DevOps Toolkit, the same one that I created a moment ago, and I will base it on the image vFarsik/DevOps Toolkit series. So I'm deploying something by specifying only the name of the application and the image that was already built. And there we go, that's all it takes. And you probably cannot get simpler than this. Actually, it can be simpler than this. We can skip building container images in the first place and deploy only based on the source code, but we're going to get there in a few moments. For now, let me list the applications I have. So Shipa app list. And we can see that there is dashboard. That's a Shipa dashboard that was installed when I installed Shipa. And there is DevOps Toolkit. We can see that one replica of the application is running. And this is the address through which I should be able to access my application. Now, bear in mind that this address can be customized. It can be any address. This is just the one that comes by default. So let me open it in browser and confirm that my application was really deployed. So I'll just paste the address that I copied from the output, and there it is. That's my application. Now, really, if you want simplicity, if you want to enable everybody to deploy their applications without much fuss, while still having control what those applications are, and I will talk about that control later. For now, think of it as only developer's perspective. It cannot get easier than this. Now, if I would like to see the details about my application, I can say Shipa app deploy list. This is the list of deployments of the application called DevOps Toolkit. And we can see that we deployed it only once. There is only one revision of the application. This is the image that was deployed. Now, this is not the image that I specified, because behind the scenes, Shipa pulled the image that I specified and stored it in an internal registry, the one running in my cluster, the one that was installed with Shipa. And we can see that the origin is image. This is the person who did it. That's the date when it was done, and there are no errors, which is always a good sign. Now, you're probably thinking that having one platform, static platform, that fits all the applications is not enough, and you would be absolutely right. So let's see how we would do something similar based on a source code of an application instead of an image. And that source code, the source code that I have right now is Go. So I would need to add a platform that is appropriate for applications written in Go. So let's take a look what we're getting with Shipa platform add command. I will do the help here, and you can see here the short instructions. There isn't much. What matters really is that we can add the platform based on some language, and here is the example of Java. I don't care about Java right now. We will go for Go because that happens to be a simple demo API type of applications that I'm using right now. But before we continue, let me show you the list of available platforms. Here we are. You can see that out of the box, if you go to the documentation, Shipa supports Java, Ruby, Node.js, PHP, Python, Go, blah, blah, blah. A lot of stuff. I mean, decent amount of languages. Now, don't be scared if what you need is not here, because you have control. You can define what a platform is. You should think of those platforms more as a way to get you up and running quickly, and it's up to whomever is managing your platform, in this case Shipa, to create the platforms that fit exactly your use case. But for the demo, for my simple application, I can go with Go, predefined platform. I do not need to create my own, so that should do for now. So where's the source code? This is the source code. I have a simple application. It's like 20 lines, very silly demo app written in Go, and it is stored in main.go. That's all I have. I did not want to go crazy and show you complicated scenarios. If you want me to do a complicated example, just let me know in the comments and I will do it, I promise. But for now, we go with something simple. Think of it as application written in Go. It could be any other language. And I want to do everything I need to do with that application. That means that I need to compile it. I need to build a container image. I need to create a bunch of Kubernetes resources. And I need to run all of those things inside my cluster. I mean, I should be testing my application. I should be doing other stuff as well. But for now, if I'm focused only on deployments, I need to build binaries, I need to build the image, and I need to create some Kubernetes resources. Anyways, what I'm going to do is add Go as a supported platform within my Shipa platform. That's kind of strange. I'm going to add platform to the platform. Anyways, silly naming. So Shipa platform add Go. You saw from the documentation, Go is already predefined. I can just add it, and it will take a couple of moments. Okay, there we are. Now I can deploy my Go applications. 1, 2, 3, 5, 10,000, doesn't matter how many applications, as long as they're following the same pattern as defined in this platform. And we are going to go through platforms in an upcoming video. Anyways, by adding the platform Go, I can deploy one or any other number of Go-based applications. So just as before, I will add Shipa app create, and I will call it Shipa demo. This time the platform will be Go, and the team is my own team, the admin team, even though I should probably have a team that is more fine-tuned, but again, that comes later. And my application was created. As you already know, creating an application just defines what an application is. It did not deploy anything, and we're going to do that next. So Shipa app deploy, application is Shipa demo, and I want to deploy the files. Basically, I want source code to be automatically converted into something that should be running in my Kubernetes cluster. Whether that means building binaries, building image, whatever needs to be done, I want the platform to do it for me, or Shipa to be more precise. So I'm going to say files only, and I'm going to say dot as the location of those files, which means current directory. And now it is uploading my files into the cluster, and it is processing those files, and it is doing everything that needs to be done. Simplified version of the steps that are being executed right now is, hey, you need to create a binary, you need to create a container image, you need to create Kubernetes resources, and you need to make sure that all those things are running inside my cluster one way or another. Okay, that was it. That was as easy as it can get. The least painful option I've seen so far. And you might be wondering now, hey, how about UI? Do I expect people to do everything through terminals? I mean, I do, but most of the other people don't. So there is a UI. So let me show you the UI. This is the initial dashboard that says, hey, this is how many nodes we have, this is how many frameworks we have, applications. I'm running 3 applications. One is this dashboard itself, and the other 2 are applications that I deployed right now, one after another. How many units we have. This is the distribution of our clusters. I'm cheap today. I'm running only 1 cluster somewhere in US, but normally if you run at scale, you would see the distribution of all your clusters, and so on and so forth. A lot of useful information, but for now, what I'm really interested in are applications. We can see here that Shipa demo, the last one that I deployed, is here. It is up and running. I can see it, I can see the details, different information, the plan, transactions, resources, units, how many of them are running, distribution, life cycle, a bunch of things. I will not go into details, that would lead me astray, but simply remember that you can see all the details you want. What I want to do for now is to confirm that this application is really running. So I'm going to copy the endpoint, the address through which this application is available or accessible, open a new tab, paste the address, and there we go. This is DevOps Toolkit. I said in advance that this is simple application. This is the simplest possible application I could create for you guys. And it just outputs a hello world equivalent of a message. Now, what would happen if I want to create a new release of that application? And for that, I will have to go back to my terminal. So let's see what would developers experience if they want to create a new release. And to do that, I'm going to modify the source code. I'm going to change here from saying this is DevOps Toolkit to saying this is, let's say, Shipa, and 3 exclamation marks or 5 exclamation marks just to make it seem very important. And that's it. I finished a simulation of a couple of hours of work. I'm finished. I did some local unit testing. I did whatever I need to do locally, and now I'm ready to deploy my application to an environment, whatever that environment is. And all I have to do is say Shipa app deploy application is Shipa demo, and I want files only, and the location of those files is the current directory. And now it will just repeat the process and apply or create a new revision of my application and make sure that it is running. That's it. I should have a new version or new release of my application. Let's confirm that. Let's see first which applications we have. Shipa app list. And we can see that application is still running just as before. There is nothing new here. So let's go into more details of that application with Shipa app deploy list. Application is Shipa demo. And we can see that we had 2 releases of this application, V1 and V2. You can see by the asterisk here inactive that the second release is active. We could roll back to the previous release if we would want to do that. We could do quite a few other things with it, at least from the developer's perspective. As I said before, we are going to go into operational sides of Shipa later in an upcoming video. Anyways, 2 releases were deployed, and the last one is the active one. So what else can we do? Let's say that, hey, I want to scale my application. How would I do that? Should I create auto-scaling groups? Should I figure out how to do it by changing some Kubernetes manifests? You can definitely do that, and that's one of the beauties of Shipa. Everything is Kubernetes. You could break the glass, you could skip Shipa and do things the Kubernetes way if you know how to do that. But if you would just to do it in an easy way, we could say Shipa unit. I want to add 2 more replicas to that application. I could set the number to a specific number, but right now I'm going to add 2. And the application is Shipa demo. This time I'm going to switch to the UI just to show you a different view of the same thing. Here is the application. Let's list all the applications again. Shipa demo, and we can see that right now 3 units are running because I scaled my application. It's as easy as that. That's all we have to do, is to say, hey, here's my code, run it, scale it, do things in a very, very simple way. If you would like to define what your frameworks are, what your platforms are, how should each type of application behave, how it should be deployed, you can do those things, and that's the beauty of it. You can have your sysadmin, SRE, DevOps guy, girl, whomever, define and fine-tune what your applications are. But from developer's perspective, it's simple. Let's finish the demo here and talk about Shipa. Now, before I give you my opinion about Shipa, or at least the part we explored, the part that is mostly in the domain of what developers should do with it, not necessarily operators, that's coming. Anyways, before I give you an opinion about Shipa, I need to tell you something. I joined Shipa. I work for a company behind Shipa product that I'm showing you right now. That being said, I am doing my best to be objective without really defending corporate interests. As a matter of fact, I joined Shipa because I think that this product has potential. I created this video before I joined them, As a matter of fact, I had to redo this part of the video, so that I tell you the news. I work for Shipa, and that might make me subjective. I'm not trying to be. I consider myself as an objective person that is not defending corporate interests. Still, you might want to take that into consideration, and you might say, hey, Victor is just doing marketing for Shipa. That's not what it is, but you decide. I believe that Shipa does a wonderful job of simplifying the lives of developers. I think that it gives a lot of potential to operators, but I did not explore that in this video, so that's coming later. It provides an easy way to build binaries, to build container images, to create Kubernetes resources, and to apply those Kubernetes resources inside of a cluster. It does many other things, but from developer perspective, that's the main thing, that's the focus for developers. I could argue that if simplicity is what you're looking for, it cannot get easier than that. We get Kubernetes, everything is open. You as operator or SRE can see what's happening, which resources are created, how, what, when, and why. You can do all those things. Still, from developer perspective, the whole process is greatly simplified. I have an application, I want to run it in my cluster, I execute a single command with a couple of arguments, or I do it through the UI, which by the way I didn't show you. Anyways, I can do it through the UI as well, and off I go. I want a new release of the application, same thing. Just a simple command or a few clicks in a UI, and I'm done as a developer. And then you as an operator, you figure out what should be the templates, how should those applications look like. And I think that's awesome. We need simplicity for those who don't want to dive deep into Kubernetes and all its quirks and issues and benefits and all the stuff. It needs to be simple for some, and it needs to provide operational complexity for others. Kubernetes combined with Shipa gives us both. Try it out. Let me know what you think. Until the next time, you know what to do. Subscribe, hit the like button, do the things you do on YouTube. See you in the next video. Cheers.